So we're continuing with question number 5 from the January 2025 Math CSEC paper, and we're on part B, which has to do with probability. So the diagram below shows two fair six-sided dice P and Q. The six numbers on die P are 0, 0, 1, 1, 2, 3. The six numbers on die Q are 1, 1, 1, 2, 2, 3. When a die is rolled, the score is the number on the top face. So part 1, for 1 mark, die P is rolled once. What is the probability that the score is not 2? So in symbols, the probability that the score is not 2 would be 1 minus the probability that the score is 2. Logically, so if the score is 2, you only have 1 2 on die P. So therefore that will be one number out of 6. So therefore, probability of getting a 2 is 1/6. So the probability of not getting a 2 will be 1 minus 1/6, which is 5/6. Let's go on to part 2. For 1 mark, die Q is rolled twice. What is the probability that the score is 1 both times? So if die Q is rolled twice, each time you get a 1 would be independent events. Right? So getting a 1 on the first roll and getting a 1 on the second roll are independent, right? Because each roll is independent of the other. So therefore, the probability of getting a score 1 both times, so that is a 1 and a 1, meaning 1 on the first roll, 1 on the second roll. So since they are independent events, probability of two events happening together will be the probability of event A, which is the first event, multiplied by probability of event B, which is the second event. So the probability of getting a 1, let's see on die Q, how many 1s are there? 1, 2, 3. 3 out of 6, which is a half. So therefore it will be 3 out of 6 times 3 out of 6, which is a half by a half, which would give a quarter. Okay, part 3. Die Q is rolled 72 times. Calculate an estimate of the number of times that the score is 3. And this is worth 1 mark. So die Q only has 1 3. So the probability of getting that 3 is 1/6. So the probability that the score is 3 is 1 out of 6. And if the die is rolled 72 times, then the expected number of times that the score is 6. So number of times that score is 3, we multiply the probability that we get a 3 times the number of times that we roll the die. So it will be 1/6 of 72, which is 12. Okay, so let's go on to the last part, part 4. Each die is rolled once. The product of the scores is recorded. The sample space diagram is shown below. Find the probability that the product of the scores is 2 or 3. Okay, and this is worth 1 mark. So you're expected to use the sample space diagram, and this hasn't come in a while in CSEC. This normally comes in AdMath. So let's understand this, right? So remember, we have two different dice. So die P, these are the scores. Die Q, these are the scores. So we're saying that if we multiply these scores together, remember they said the product of the scores is recorded. So if die P you roll a 2 and die Q you roll a 3, then 3 by 2 gives you 6. All right, so that's how this sample space diagram was created. So we want to find the probability that the product of the scores is 2 or 3. So let's count how many of the scores, the product of the scores that is 2 or 3. All right, so let's look at the 2's. So we have 1, 2, 3, 4, 5, 6, 7. Okay, and let's count the number of times that the product of the scores is 3. So that's 1, 2, 3, 4, 5. So altogether, the product, when the product of the scores is 2 or 3, that will be 1, 2, 3, 4, 5, 6, 7 plus 5 is 12 out of 36 possibilities, because remember it's 6 possibilities for die Q and 6 possibilities for die P, so that's 6 by 6, 36. So it's 12 out of 36, which is 1/5.